Hello everyone and welcome to a short video from Elvyn Capital Financial Technology series in which we are briefly discussing key concepts used in modern finance technologies in a comprehensible manner and within the context in which they have practical implication for finance and legal professionals. In today's video, we'll be looking at the concept of hash and discuss how it operates and why it is becoming a big part of everyday transaction practice. The reason why it is a good idea to have reasonable knowledge of hashing is that hashes are one of the key concepts behind modern solutions based on blockchain, digital signatures, smart contracts, and many more. An understanding of the fundamentals of what a hash is indispensable for understanding of these technologies. Although the mathematics and cryptographic concepts behind hashing are relatively complex, the concept of hash itself from the practical perspective is relatively simple. A hash is a result of a mathematical function. A hash function, just like the simplest mathematical functions, takes an input, applies predefined rules to change it and produces a result. The thing that makes hash functions special is the fact that they are mathematically designed to be unique, meaning the two different inputs cannot produce the same result. This also implies that the slightest change in the input will produce a different result. And B, that they are irreversible, meaning that if you are given the output, you cannot figure out the original input. These two features are what gives hash functions a wide variety of usage in transactions. Invention of hash function has allowed us to make a difference between being able to verify whether two pieces of information are identical and knowing what either of these pieces of information actually is. In order to demonstrate the power of this idea in practice, let's first take a look at a simple example of how hashing is used in database applications, as this illustrates the point plainly, and then we will move to examples relating to financial transactions. One of frequent uses of hashes in database handling is storage and verification of passwords and other sensitive client information. This is a situation in which hashing is often used because you need to verify the information provided to you by a user, but you do not want to know the information. You need to know if a user has entered the correct password, but you usually do not need and even do not want to know what the password actually is, let alone to have it stored in your database. The main reason is that having the actual password in your database only means a liability, and potentially a costly one, if data from your database are stolen or leaked. This is where hashing comes up on the stage. Let's imagine that a user sets up an account and chooses a password secret_password123. A terrible password, but it is okay for the sake of this example. When the user hits the register button, the password is not directly sent to the database, but firstly it is ran through a hash function. If, for instance, SHA-256 function is applied on the secret_password123, it will turn it into 10376 nonsensical text, which, as you can see, bears no resemblance to the original input by the user. When, subsequently, the user tries to log in, whatever password he or she enters is again ran through the same hash function. If the password entered by the user is exactly the same as the one that the user chose in the previous step, secret_password123, then the hash popping out from the hash function will be exactly the same as the one stored in the database. The administrator of the database has no idea what either the original password chosen by the user or the password used by the user now are, but given the fact that the hash for each input is unique and the hashes are the same, then the password chosen by the user at registration and the now used password must be the same. If, on the other hand, the password used at login was even slightly different from the one the user chose at registration, for instance, if the underscore were replaced by a blank space, the hash produced by the hash function would be completely different. If the database is breached by a hacker or other unauthorized person, what they find in the database instead of the actual passwords are nonsensical ciphers, which, as we discussed, cannot be reverse engineered to the original passwords. This idea becomes even more uplifting when you realize that PDF and other electronic forms of documents are nothing but chunks of computerized information that can perfectly serve as input for a hash function. Imagine the impact on time, money, and human capacity spent on verification of conformity and integrity of documents in situations like collection of CPs, escrow documents, letter of credit presentation, and many more. How immensely faster and cheaper transactions will become, and how deeply affected will the role of lawyers, escrow agents, facility agents, notaries, and others become. This becomes even more profound when this is taken to another level and when you take into account the technologies that use hash functions, build on them, and create a wide range of new opportunities like blockchains and public key encryption that will become our topic in the next videos. Hope you enjoyed this episode, and we at Elvyn Capital will be looking forward to seeing you at the future videos from our credit agreements, financial technologies, and other series that we are preparing for you in the future.